A lot riding on this SpaceX Falcon 9 rocket for APL-UW oceanographers Ale Chase and Peter Gaube.
2, 1, booster ignition. Full power engines and liftoff of the Falcon 9 and PACE sphere.
PACE is a new NASA satellite.
Stage 1 propulsion is nominal.
Plankton, Aerosol, Cloud, and Ocean Ecosystems mission.
Payload separation confirmed.
It will be observing the Earth globally, daily, using several different instruments to understand better the oceans and the atmosphere.
The primary instrument aboard PACE, the Ocean Color Instrument, or OCI.
The OCI is extremely exciting for science because previously NASA global ocean color missions have measured ocean color, the color of the water in the visible wavelengths, but at several discrete wave bands or colors in the visible light spectrum. You can think about how green the water is as a metric of how much plankton is there, because phytoplankton contain the same pigments that land plants do. So the more plankton biomass in the water, the greener the water becomes. And so for decades, NASA has made measurements that let us estimate total plankton biomass really from how green the water is. But the OCI instrument will measure every few nanometers. With the OCI, we'll be able to parse out subtle differences in the greenish, bluish hues of the ocean that we haven't been able to do in the past. Different types of phytoplankton have different features in their spectral absorption signatures. And with more information from OCI, we hope to be able to tease out the presence of different major taxonomic groups of phytoplankton.
3, 2, 1, engine ignition, and the liftoff. Liftoff of SWOT, our first global survey of Earth's surface water to study how this ever-changing resource affects our climate.
SWOT is an altimeter which measures the height of the ocean. And from the shape of the sea surface height, we can estimate currents just based off of the slope of the sea surface height. Now that we have PACE launched at the beginning of 2024, we've kind of entered into a new era where we can really look at the role that currents have in the ocean, especially fine-scale currents, ones we haven't really been able to study before. What role they have in structuring life, phytoplankton communities, and the different changes we'll be able to see for the first time from PACE.
For years, I've been looking at measurements made on ships, actually, so not from satellites, but we make measurements on ships of the spectral light absorption and reflectance, and then we also collect data on the phytoplankton communities in the water. And by linking those two types of measurements, we start to develop algorithms and proxies so that we can understand what we expect to see in the water when we make a certain optical measurement. So as a graduate student, I received a NASA fellowship to conduct research on these methods in support of the PACE mission. And then I had a proposal funded to participate on the science and applications team for PACE, and that funded my postdoc work here at APL, and also the start of my research here as a PI. And then most recently, I've received funding through NASA for a proposal I submitted to support PACE mission validation. So for the next 3 years, I'll be leading a team of researchers who will go on ships and make measurements in the ocean at the time of PACE satellite overpass for direct comparison of the PACE products to what we measure in the ocean to help validate and evaluate the PACE products. Discovering new things is really an exciting part about science, and with PACE we'll be able to do that, and that will steer our research in new directions.